Welcome to 8.3, which is our intro to trigonometry in geometry. So we've learned about the Pythagorean theorem this unit. That was the a squared plus b squared equals c squared, which we did in 8.2, and that helped us calculate different side lengths in a right triangle. However, we haven't really talked about how you could change between angles and sides or sides to angles. But that is exactly what trigonometry lets us do. Before we set up our formulas, of course, we need some vocabulary. The reference angle is the angle that we're focusing on in the triangle. In our diagram to the right, there's only one angle that's labeled, and that's this guy right here, T. So in the diagram, this is T. Let me highlight them. T's in the corner here. The hypotenuse we learned when we talked about the Pythagorean theorem, and that's the side that is across from the right angle. So if we look at our right angle down in this corner, the hypotenuse is C. Oops. And we'll give that the same color too. Hypotenuse over here in orange. Then we have a side that we call the opposite side. The opposite side is the one that is opposite from our reference angle. In this diagram then, that makes it B. One thing that's important to point out is that the reference angle can move around depending on the problem. Sometimes it'll be right here, sometimes it'll be here, it could even be our right angle. So what we call the opposite or the adjacent sides can change depending on what problem we're doing. We've gotten C labeled, we've gotten B labeled. We must need something for A, and that would be the adjacent side. Adjacent in English just means next to. So this is the side that is next to the reference angle, and it's also not the hypotenuse. In the diagram, this is A. Perfect. So we've gotten all of our pieces labeled. Then the trig functions sine, cosine, and tangent. These are all functions that you can type in on your calculator. They tell you about the ratios of the sides in the triangle. You will never need to memorize what values you get for sine, cosine, and tangent. You will always be given a calculator where you can type that in. You can remember which sides to use with each function because there are 3 different functions, sine, cosine, and tangent, using this mnemonic device, SOHCAHTOA. SOHCAHTOA. And the way it works is that the S stands for sine, and in a sine function, you do the opposite side over the hypotenuse. In the cosine function, you do the adjacent side over the hypotenuse. And in the tan function, you do the opposite side over the adjacent side. So let's take a look at an example here. Calculate the sine, cosine, and tangent for the triangle to the right. Our reference angle here is T. That's the only angle that's labeled up here in the upper right-hand corner. You can see that this angle is what gets plugged into each of our functions. So we're calculating the sine of T, the cosine of T, and the tangent of T. For sine, it is the opposite over the hypotenuse. So if we find the opposite side here, that's 4. And the hypotenuse, that's the one across from our right angle, that's 5. Then we know that the sine of T is 4 over 5. If we want the cosine of T, we need the adjacent side over the hypotenuse. So if we look at our definitions, the adjacent side is the one that is next to the reference angle and also not the hypotenuse. So you might think, oh, it's next to T, so maybe it's this side, but that guy's the hypotenuse. So 3 here would be our adjacent side. And then we're using our hypotenuse again. Hypotenuse, which is 5. So our cosine of t is 3/5. Finally, we want the tangent of t, which would be the opposite side over the adjacent side. Our angle that is opposite of t is 4. So our tangent of t is going to be 4 over adjacent, and adjacent is 3. Those are the ratios that our trig functions give us. Look at the practice problems in the next section and see if you can calculate the following trig ratios. While you're doing this, pay particular attention to what angle you're supposed to be focusing on. If you look at the pictures, all of them have an angle A and an angle B, but the problem tells you which one you should be using as your reference angle. You should pause the video here, in order to do the practice problems, and then you can check your answers using the answer key, or I will show them on the board in just a second. Here are the answers to the practice problems. You can pause on this screen if you need a second to check your answers. Again, make sure that you're paying attention to the correct angle. In the next section of notes, I'll show you why this setup is useful. So far, you're like, okay, we're just making fractions with the sides, but I don't understand how that actually helps us. The reason this is helpful is because we can use this exact same setup to find a missing side in a triangle. So look at the triangle over on the right here. We know this angle is 11 degrees, and we know that this side of the triangle is 80 units long. Imagine you're building like a part with a machine, and you know that this has to be a certain size, and you know that this side needs to be a certain length. Maybe you need to figure out then how long this piece needs to be. Instead of having to build it and try it out, you can use trigonometry to figure out how big this angle or this side needs to be. There are a couple guiding questions to help you set up your problem. What is our reference angle? So the only angle that we have labeled here, the one that we're focusing on, is the corner labeled M, or you might also write that it's the angle that's 11 degrees. In reference to that angle, what sides do we have? There are two sides that are labeled. There's an 80 over here and an X over here. 80 is across or opposite from our reference angle, so we'll call that the opposite side. The hypotenuse is always across from our right angle, so this has to be the hypotenuse. So that makes our remaining side, the one that's labeled with X, our adjacent side. So, in reference to our angle in the corner here, what sides do we have? Well, we have an opposite and we have an adjacent. So O for opposite, A for adjacent. Question 3, what trig ratio uses those sides? Well, if you look up to your notes at the top and you remember SOHCAHTOA, the O and the A go with the tangent function. With these three parts, we can now set up our equation. We're going to start with our trig function, or trig ratio, which we know has to be tangent. Next to the tangent, inside parentheses, we write the angle that we're using. In this case, it's 11 degrees. That is going to be equal to the opposite side over the adjacent side. So our opposite side was 80, and our adjacent side is X. There is our setup equation. One thing to point out is making sure that your angle goes here. The angle always goes next to the trig function. The other side is where you have the hypotenuse or the opposite or the adjacent side. So this is how we take an angle and it turns it into sides in the triangle. Now we need to solve for x. We want to get x by itself, so I'm going to get it out of the denominator here by multiplying both sides by x. So if I multiply, that's hard to see. If I multiply this side by x and multiply this side by x, on the left I will have x times the tangent of 11. Don't be weirded out by the fact that this has lots of letters. Tangent of 11 is just an ugly number, but treat that whole thing as though it were just a plain number. On the right side of the equal sign, we have 80 divided by x times x. So the two x's will cancel each other out, and now we have just 80 on the right. Then finally, we want x by itself on the left. Right now it's multiplied by the tangent of 11. So to cancel that out, we will divide by the tangent of 11. Divide tangent 11 degrees. So we now have x by itself on the left because these cancel out. And on the right, we have 80 over tangent of 11. Finally, we can get an actual number from that if you type it into your calculator. So I'm going to type 80 divided by tan, which is its own button on the calculator, right above the parentheses on your yellow TI-30 calculators. And then I'm going to type in 11 and press enter. And the answer I get here is 411.56. So what that has now told us is that if we were actually to build a triangle like this, where we made this angle a teeny tiny 11 degrees, but we also wanted this side to be 80 units long, then in order to build that triangle, this side has to be 411 units long. Follow the questions in the section below to solve for the missing sides, and then check your answers using the answer key.